Hello everyone, I'm Umima Osman.
And I'm Kate Harborne.
And we are both PhD students here at ICRAR.
And today we're going to be answering questions from the International School of Western Australia.
If you think that life could develop on another planet somewhere in space.
How many planets do you reckon could support life?
And how far is the human race from discovering other life forms?
I wonder whether life exists elsewhere in the universe.
So, life in the universe. There are a lot of people, not only the students, are curious about all the odds and possibilities of having life somewhere else outside of our solar system.
And this means not just human life that could be of other forms, and outside of our own galaxy even, right?
Yeah.
So a really good way to start broaching this topic and look at the odds of how likely it is that we will find intelligent life is with the Drake equation. Now, this equation has people who really like it and people who really don't like it, because it means you're just putting together a bunch of parameters to describe the odds of finding civilizations that can communicate in a form that we can pick up here on Earth. So this equation has 7 terms in it, and it just brings across a couple of things we need to think about. So, for example, how often do stars form that are like our own in the solar system, like our sun? Will they be suitable for intelligent life to form on planets around them? Yeah. How many of those stars have planets that life could form on? Are those planets in a suitable position around that sun? Are they in what we call the Goldilocks zone?
What does that mean?
Where bears can be.
Okay.
Not too hot, not too cold, just the right distance away that life can evolve on that planet.
Okay, fair enough.
Now, not only does that planet have to be in that Goldilocks position, there is also a fraction of those planets that might not form life. They might not have the initial seed that spreads into the first slug that crawled out of the ocean. And then you've also got a fraction to talk about whether or not that slug that crawled out of the ocean actually evolves into something that is intelligent.
Like ours.
Like ours. And then beyond that, can they communicate? Can they evolve to the point of creating an electromagnetic spectrum that gets sent out into space? And then finally, and this is the crux for me, is the length of time that it takes for that process to happen, and for our process to happen on Earth. And what are the odds of that process overlapping with our process and actually being able to intercept signals?
Yeah, that's very hard, really hard.
And the crux here is that space, to quote Douglas Adams, is very big.
My question is, if the sun were closer to any of the planets, how would they change?
Well, for example, let's take Mercury and Venus. They're very close to the sun, and on those 2 planets, the temperature is just into extremes. During the day, it goes up to the vibration point of the water, and during the night it just freezes. So we don't have the condition of liquid water that supports life.
So we're talking during the day temperatures of like 500 centigrade.
Yeah.
This isn't just like Australian summer temperature. This is not livable.
Yeah, that's true. That's very true.
And then during nighttime it's minus the other way. So minus 200 degrees centigrade. That's, again, not comfortable for human life.
No, unless you want to freeze out. And then when you go further away from the sun, for example, you go to Neptune, Pluto, Uranus, all of those planets are known as gas giants, formed out of gas, and the temperature is just so low, and even if there's water, it's frozen.
What is dark matter and how does it affect the universe expanding?
How fast is the universe expanding?
We know only about 5% of the matter in the universe.
So that's baryons?
Yeah, this is a baryon.
The stuff that makes up us. Things, the atoms, the particles that make up human beings, all of the trees, all of the birds,
galaxies, planets,
Galaxies and
everything
planets.
that we can actually see. And there is about 25% which what we call dark matter, and 70% of dark energy. And when we say dark energy and dark matter, that's a code of we don't know what they are.
If it says
So-
dark,
Yeah, so it just means that we don't know what the nature of dark matter and dark energy. So to answer the question of what is dark energy and dark matter, we actually don't know yet. We have some candidates, but they are not confirmed.
so in terms of that 24% of dark matter in the universe, we have got a name on the end of their matter. We know that dark matter, or some form of matter that we can't observe, does exist, and we see it in the form of galaxy rotation curves.
Yeah.
So you know that when you're like sat on a roundabout, or do they have roundabouts in Australia? I don't know. I'm from the UK. I don't actually know.
Me neither.
When you sat right on the edge, you know that when you're spinning, if you're further out, you're going to spin slower. The further you go from the center of your rotation, your rotational velocity will get slower.
Yeah.
Which makes sense in terms of galaxies. But when we actually make our observations, that's not what we see. We see that as we go further out, we're actually plateauing. Everything becomes a constant speed.
Yeah.
And that implies that there must be some matter, some gravitational force, something in there that is causing the stars at the outer edges that we can see to still rotate at that speed, which is where the idea of this dark matter comes along.
Yeah, exactly. So this is one of the signs of dark matter. We can infer the existence of dark matter, but we can't see it directly.
Exactly. And there is plenty of research going on into that. Now, dark energy, that's a bit of another
Yeah.
wormhole of ridiculousness. Dark energy, we think that it's causing the expansion of the universe.
Yeah.
And for that expansion, everything to be moving away from one another, for that to be accelerated.
To answer the question of the rate of expansion of the universe, I would say it equals what we call Hubble constant, which is ranges between 76 and 72 kilometers per second times megaparsec. I know it's a ridiculous unit.
Megaparsecs are huge.
Yeah,
In
they
fact-
are.
Space is huge, so
Yeah.
it seems appropriate.
So it's 1 PC or parsec is 10 to 16 meters, and you can imagine what megaparsec means.
Black holes are actually a form of wormhole, and that we could create such transportation.
Can you use black holes for transportation?
Okay.
So first of all, what is a black hole? So
Yeah.
I'm going to throw out there space-time, which is what we think the universe, the fabric of the universe. I like to think of space-time as a big sheet, like your bed sheets. And you know that when you put mass, so ping pong balls, on your bed sheet, they bend the bed sheet, right? So space-time is like a bed sheet.
Yep.
The more massive the object that you place on your sheet, the more it will bend space-time.
Of course.
So what happens if you put something really, really heavy on your bed sheet?
Will I get a hold on it?
Potentially. So that's the idea.
Okay.
Black holes are where a point mass, an infinite amount of mass, has pushed through the surface of space-time. It's pushed through your bed sheet and made a hole. Now, if your bed sheet was folded all the way around on itself and two holes, two really infinitely massive objects pushed through it exactly the same kind of space, and those two black holes lined up, maybe you could move from one point in space, from one point on your bedsheet to the other point on your bedsheet. And that's the idea, at least proposed by various physicists, also various sci-fi writers. But there are some problems. What happens when you get very close to an infinitely massive object? A wonderfully named process, spaghettification.
Oh my god, that sounds terrible.
Do you know what happens during spaghettification?
Well, I can guess that you will become spaghetti.
Exactly,
Oh.
exactly. So as you're falling into a black hole, your atoms would get pulled, and atoms at the ends of your fingertips would get pulled more than the atoms like at your knuckle. And so this gets pulled into an infinitely thin string, and everything gets pulled at different rates so that you eventually become spaghetti, Omima.
Oh my
rather than
god, that
amoeba.
must be really painful.
Exactly. So, in terms of experimenting with actual transportation of humans through black holes, I think it's beyond our current capabilities.
Yeah, I would think twice.